and inheritance and polymorphism are the last topics for this lecture. Okay. So, what the inheritance is? So, inheritance based on the assumption which is, originated from real life. So we assume that we create an object, or more general, a class, which inherits properties, attributes from other classes. But the difference between the real life and object-oriented programming is that in real life, when we have, let's say, our Mr. Fedorovich, we will be talking about lectures, about exam tomorrow. So tomorrow I reserve, I think, about 20 minutes to tell you something about lectures. But answering your question, yes, programming is also a part of exam. So exam will consist of both the blocks, so programming and computer hardware. So okay, so so comparing to real life, when we have biological mother and father, we inherit 1/2 of their genome, yeah? So not everything, but only a part of their features, and it is randomized somehow. In case of class inheritance, the class can inherit from more than 2 classes. It can inherit also from a single class, but it gets all features, all attributes of the parent class. So you have to know it. So there are several names or terms I will use during this lecture. So a new class which inherits some from the other classes, it is called derived or children class. And the parent class is called base class or parent class. So what is typical for inheritance? So it gets all methods and member variable from base class. So everything, so almost everything. So methods and member variables. So the second feature is that it can have additional variables and methods. So let's say extra methods. And the second feature is that it can overload some member variables and methods. So some methods can be, derived, and other methods, even they have the same name and the same set of parameters, can be overload. Okay. The second information about derived class is that the private members of the base class cannot be directly accessible. So they are encapsulated like for standard object user. So of course they exist, but you can't directly modify them. The same is true for private methods. If methods are not private or attributes are not private, the derived class is able to modify them directly, so it has direct access to them. So when we think about wait a moment. When we think about inheritance, you have to remember that there is a base class or a base classes, and the class which is child class consists all of them, and it can have some additional elements. So today I'd like to tell you about the protected access type. So far I showed you two access types, so public and private. So it is okay for when you don't use inheritance, but if we use inheritance, we have another access type, so additional access type which is protected. So derived class, if the access type is set to be protected, derived class can directly get access to attributes and methods. But protected type works like private type for object users. So if you define object, the derived, okay, if you defined object and methods or attributes are set to be protected, they can be directly accessed. So let's try to define a simple class. Oops. Okay, I have to So let's start from the example of class, which will be class point 2D. So I'd like to have class which defines the point in two-dimensional space. So in this case, I can have float x and float y, and public method which can be so for example I can have point to the constructor, so int float x equal to 0 and float y equal to 0, and then let's make it different. So x is equal to x and y is equal to y. So here I have a definition, a constructor definition. Not equal, not, okay. I have initialization list and the body of constructor is empty. I can have method void print. And this method simply prints x and y. Okay, so it is super simple class, but you know our aim is to see some problems or features of inheritance. So if I'd like to use this object, I can write point to the point, and here I can specify the coordinates of this point, and finally I can print it. So the result is like that. Okay. So now I'd like to create a class point to the 3D. But I'd like to make this class not, you know, separate class. So the class which has everything the same and plus something, but because point 3D is point 2D plus some features, I'd like to use inheritance. So in this case, I can set that the class point 3D inherits from point 2D. So it tells a compiler that this class is child class of point 2D class. So now I need only to define what is changed. So which elements changes. So what is changing? So float z. Yeah? So this is an additional element which has to be defined to have, you know, 3D point. What else? Okay, if we leave these elements, other elements unchanged, so let's try what will happen if we like this. Okay, I should tell you something about inheritance access rules. So similar to so in fact, when we inherit from or derived from the base class, next to the base class name, we should insert access type. So this argument is optional. So you could see that the program can be compiled, but by default, the access type is private. So what does it mean? It means that, wait a moment. Okay. It means that if we inherit particular class in private mode, in private mode, all attributes and all methods of of base class are private. So they are set to be private. So public methods and protected methods are private, and private methods, as I told you, are not directly accessible. So what is the effect here? If I try to define point 3D, I can do it. But when I write point print, you can see that for point 3D, print is private member of point 2D because the inheritance access type is by default private. If I said what do you mean one-way ticket? Yeah, it is, you know, encapsulated. So this methods exists, but they can be directly accessible. So it maybe good comparison is that when you, for example, build a coffee or hot drink machine, you have, you know, external case, but inside you also have a controller, for example. So the controller is the object itself. Yeah. So from the perspective of hot drink machine, the controller is inherited as a private element. Yeah. So okay, you have partially right, but it's not the all true. Okay, but I try to show you. So if I make it public, so I inherit point to the as a public, you can see that print can be used here. So now it is accessible. So when I run my code, you can see that 0, 0 was printed because print is taken from the base class. So it prints only 2 coordinates. What is important? When we inherit from the derived class, everything is inherited. So attributes, methods, but not constructed. So constructor is not inherited. So in the sense that it cannot be used here. So I can't call, for example, 1, 2. So there are no constructor like this. So constructor belongs to the class, to original class. So now I can create my own constructor. So point 2D, I have to have point 3D and float z equals 0. And now on initialization list, I can initialize a base class, sorry. So I can call call the constructor of the base class and then the constructor of my attribute z. So look, this is implicit call of the constructor. In fact, when the object is created and it contains a base class, first the base class is allocated, and after the attributes are allocated. Yeah, so this process works like that. So first all base classes, then attributes, additional attributes. So now I can define my point 3D, and x and y will be initialized by this constructor, and additionally z will be initialized. So now when I print it, still look, void print is so this method is called, but this method, because it belongs to point 2D class, it prints only this element. Okay, so now I'd like to overload print method. So I'd like to write my own print method. But look, yeah, okay. So look, x and y are private. So because they are private, and let's go to this slide. So if the member variable is private, it's not accessible in derived class. So the solution is, okay, I can use a setter for it, or getter for it. But the second possibility is that I can modify the access type. So if I set the access type as a protected, this element is derived as a protected. So it is accessible. So let's try to modify. Okay. For Z, it doesn't matter because, okay, when the child class is the last one, it can be private or protected. So now look, if I have the base class which is protected, it works okay. So now I can get access to x and y. but still, when I try to get access to this element as the user of this object, X is protected member, so still it is encapsulated. So protected access mode is, something in the middle between private and public. So it gets more, let's say, benefits or for derived classes, but it is still not accessible for the object user. So still the hermetization or encapsulation principle is met. Okay, okay, so the question is when we should use private and when protected. Okay, it depends. If we have the object and then we derived a base class which should have the full access right to all elements, it is easier to make it protected. Otherwise, we should use setters and getters to get access. But because the setters are getters and getters are, functions, so calling function takes time. So to make our program more efficient, it is better to define them as a protected. But if particular attribute needs some extra action when it is modified, you should always define it as private, because there are no guarantee that even in inherit or in a child class, the developer will initialize or make all the steps properly. Yeah? So in this case, this element should be always private. Okay, so let's talk about the print. So in this case, I can define print on this way. So look, X, Y, Z can be accessed. So the same, like, there are no difference between X and Y, which are defined in parent class, and Z, which is defined in our class. Yeah? So you can use them the same. Okay, let's assume that the X and Y are private. So in this case, I can write something like this. So I can call a print method. So look, print is overload, but I can call a print method from point to D. So even the method is overload, I can still call this method by using the scope operator. Yeah, so so I can define from which scope the print to D should be called. So by default, if there are no information, it is called from the nearest scope. So it will be a recursive call. Yeah? But if I call the print to D, it will be taken from this. So look, even the fields are private, it should work properly. So it works. So these two elements were printed by point to D, and this extra term was printed in point 3D print. Yeah? So in fact, it's up to you. Of course, it seems to be more, the readability seems to be higher, but this is also okay. So we take the original method and we add some additional action to it. Yeah. If fields are protected, both of these two methods can be used. So look, now if I have two classes, so I have point 2D and point 3D, I can run print. When it is run for point 2D, I get two coordinates. For point 3D, I get three coordinates. Yeah. Okay. So you should remember that if the method in base class is public and the inheritance mode is also public, you can, or the object user can call all methods or public method from derived class. So I told you that everything is inherited except constructors, but there are some other exceptions. So assignment operator and destructor. So for constructor and destructor is quite, it's quite clear why, but what about the assignment operator? I haven't tell you about assignment operator, but I try to give you some extra information about it. So look, if I have point 1 equal to C point or point 2D 25, in this case, an assignment operator has to be run. What is this assignment operator? So this is the operator which assigns value from right side into the variable which is on the left side. The good news is that this operator is defined by default. So you don't, in most cases, you don't need to define it because it makes a binary copy of object. So it takes the original object and it copies byte after byte to the new one. So it works for most cases, but look, this example is not, strictly related to point, but let's assume that I have an additional element. So let's say char label. So it led me to assign a label for every point. Because I don't know what is the number of characters, I'd like to allocate this memory dynamically. So depending on the number of characters, I can resize my vector. So let's assume that I will allocate memory for it. New char, let's say 10. And in a constructor, I can set that str copy label point. But what would happen if I should also have, in this case, when I allocate memory dynamically, I should have a destructor. So delete label. So in this case, I should have, maybe void set label. And now I can of course here I should verify whether current number of elements is enough for storing this name, otherwise I should reallocate and so on. But it's not the main feature of point, but I'd like to show you something. So now if I, for example, if I have a print function, I can start from the point name and then I will print other coordinates. So what happened if I call default operator, so default assignment operator? So because it is binary copy, print, and now look, maybe I create point 2. So I will assign point 2 to it. So I print point 1 now, point 2 set label vertex. And now again print point 1. So look, I copied the value of point 2, and now I'd like to print this value. Then I change the value of point 2, but I print point 1. So let's look what will be what is the effect. Okay, so look, I have point 1, 1, 4, and point 2, 5, and vertex. So let's try to follow it. So look, the first print is print 1. Then again, the point 1 is printed. So now it has, you know, different value because of point 2. And when I change the value of point 2 vertex, you can see that the point 1 has the same name. If we copy objects, we assume that they are not further, you know, connected, because I passed only, or I tried to arrange only values in this point in line 43. So if I modified something further, it shouldn't affect the point 1. But because assignment operator makes binary copy, it copies coordinates and pointer. So from this point, point 1 and point 2, they share the same pointer. So whatever you do with this pointer in, let's say, point 2 object, it will affect the point 1. So in this case, I should define the copy operator by my own. So sorry, not copy, but assignment operator. So how assignment operator has to be defined? Look, the assignment operator is method of, you know, left value. So I can have method which is called operator equal, and then the attributes or argument of this method is point to d. But I should use const point to d reference point. And here inside, I can write this x is equal to point x. And this y is equal to point y. But I can't write this label is equal to point label, because in this case, I copy only the address. I have to use string copy to copy not address, but elements. Okay. Now I have to define type of this operator. What do you think? What should be the type of assignment operator? Void, okay. If it is would be void, of course, it can be, but it's not a typical form of assignment operator, because in case of assignment operator, I can use 0.1 is equal to 0.2 is equal to 0.3 and so on. Yeah, so I can create a chain of assignments. So similar to cout. So to make it consistent with ANSI C standard, it shouldn't be void. So to make it possible to work like this, the 0.3, this operation should return the same object. Yeah? So this the assignment operator should return 0.2D. But to make it faster or more efficient, we return not a copy of the object, but a reference. So here I return, myself. So asterisk this, it refers to value of the object I'm using. So it should return a reference. So it doesn't create a new copy, but it returns the object itself. So this is pre-perform for assignment operator. So now I can, if I have 0.3, you can see that this form is allowed. But what would happen if I try to if I try to assign to 0.1 point? Look, it works fine. So I can, for base class, so 0.1 is 0.2D, I can assign derived class. So how it works? What do you think? What will be done in this case? Or what will be copied in this case? So point is 0.3D, 0.1 is 0.2D. So what will be printed when I write 0.1 print? What do you think? What will be printed here? All three values. Okay, let's check it. So maybe to make it more, so cout point 3D casting. Okay, so look, and finally I add okay, so I have point 3D casting to 2D case, and here I have original point 3D. So look, when I cast point from 3D to 2D, I get, look, the point in two-dimensional space. Yeah, because casting consists on derived class contains 2E plus an extra elements. So when I try to cast the objects from 3D to 2D, only this part is copied. No? The other elements are, neglected. So only X and Y were copied, and because I have point 1, which is 2D case, only the method print, which belongs to point 2D, will be printed. So only 2 coordinates. But still, the original point is like this. Okay. So here you have the example I showed you before. And the two methods which can be used to display elements. Okay, so you can analyze the slides. I think that I told you this element about these things, but for example, during your exam, there can be a short code when I have, a class example. So I have private, protected, public method, and the base class is derived. So the child class inherits in public mode or protected mode, and you can define which of use cases. So I have child class, and I try to get access to private, to protected, or to public field of the base class. And you have to analyzing the access type and the access type of elements. You have to define which of this operation is allowed. No? So maybe you will mark the operation which can be performed. So now if we have private, protected, public, and we have method test. So we can, from the base child class, we have access to protected and public. So these two operations are allowed, while this one isn't. Yeah. From the when we use the object, only the public field is allowed, provided that the base class was inherited in public mode. So you can analyze it. So you can analyze what is allowed inside the child class method and what is allowed for the object user. Okay. Similar to overloading of the methods, we can also overload fields. So you can have class A with field int x and class B, which inherits A as a private, and there can be also field of the same name. It may differ in type, but okay, let's assume that it has the same name. So whenever you write sol x, it means that the attributes which is the nearest. Yeah, so it will be always the x of class B. But you can use the scope operator, so you can literally tell the compiler that you mean the x defined in scope A, so defined in class A. So in this case, you can get access to this element. So it is similar to case I showed you last time when there was the argument name, the same like attribute name, and the same like a global variable name. So the same you can use the scope operator. So I told you that the constructor and destructor are not inherited, but it doesn't mean that they are, deleted or rejected. They cannot be, implicitly called for the derived class, but still they can be called to create or to destroy the parent class, which is embedded into the child class, but they are not implicitly called. So now we start this is quite easy, yeah, but for beginners it's quite hard to understand, because here we have only two cases to analyze, but for some of you it may generate some problems, but let's try to do it. So here I showed you an example where I assign a child class to base class. So I assigned value of child class to base class. So the effect was that, okay, it is possible the subset from the child class, which is common to base class, is taken, and these elements are copied. But if I try to do it opposite, So when I try to assign base class to child class, it is not allowed because, a base class has only a subset of information about child class. So it led to initialize only several attributes, not all of them. When we assign value, we assume that all attributes should be initialized. So in this case, it can store only information about X, Y, and label, not about Z coordinate. So compiler, by default, doesn't allow for this for such assignment. Okay. So now the question is, what about pointers? So let's say that I have point 2D, pointer P1, okay, P2D1, and P2D2. So I have 2 pointers, and also I have point 3D and pointer P to 3D1. So the question is, what can be assigned to the pointer? So first, let's take the pointer 2D. And here, when I'd like to assign address, I can assign, for example, address of point 3D, so 2D, so point 1. And that's it should work. So potentially, I can call, let's say, print, for example. What else? So let's try to run it. So look, when I have pointer 2D and I assign the address of, let's say, point 1, I get the effects. So I get the value of point 1. I can assign also the pointer 2D to another pointer. So, so I can assign the value of one pointer to another pointer. So it is still allowed. So in this case, I can call this method for pointer. So for pointer 2. So the result should be the same. Huh? So look, it works the same because they point to the same object. So they point to the point 1. So it doesn't matter whether you call print for point 1, print for P2D1, or print for P2D2, because they point to the same memory area, the result will be the same. What about 3D? So of course, it is clear that to 3D, point 3D, I can assign, for example, the address of point 3D, so point, because it's by analogy with point 1. But what about the address of the point 2D? So when I try to assign the address of the base class, it is impossible. The same like it is impossible to assign a value of the base class directly to the derived class. Because the derived class is something bigger than the base class. But if I do it, let's say opposite, so I try to assign value from the child class to base class. Okay, 3D is not initialized, so simpler I can assign the value of the address of point. So point is a variable which belongs to point 3D. So I can use it. So I can take address and look, I can assign this address to point 2D. So now, look, I assign only address. So this object is not copied. It exists in memory as the object 3D, but I assign it as the address of type point 2D asterisk. So let's analyze. So I have pointer 2D 1. So I have point 3D casted to pointer 2D. So what happened? So my point 3D has three coordinates, 3, 3, 0. But when I casted this element, even the object exists in memory, but I casted the pointer to two-dimensional point, the result is that I get only 2 coordinates. So only the method, which is created for two-dimensional case, was called. Even there is more. Okay, this method. Even there is. There is enough information to print every element. So even there is enough information to print Z, because still, even we have pointer which was converted, the point 3D is allocated. Okay, so now it's time to start talking about polymorphism. Tomorrow I will try to combine it with OpenGL, but today I'd like to introduce to this mechanism. So polymorphism consists on the, so it is mechanism which led us to call not the, so if we use pointers, it led us to call the most proper method for particular object. even we use or we casted pointer to the base class. So look, in previous case, so in this case, when I casted the pointer from 3D to 2D, the method for 2D was called, even the object is 3D. But the polymorphism led us to cast the pointer and call the most proper method for particular class, so particular object. So if we casted the pointer from point 3D to 2D, the method for 3D will be called. If we have pointer to point 2D, like in this case, the method for point 2D will be called. So how can we do it? The clue is that the certain method in base class should be declared as virtual. And the second is that this method in child class, the particular method, will be override, so overload. So let's try to declare this method as virtual. And now I try to run this code again. So look, now even I run the method print for pointer 2D, I get the method which is suitable for point 3D. Okay. So it makes the difference. So when you cast pointer, there are the compiler, not compiler, but on runtime, the best method is selected. Of course, it works only for methods which are virtual methods. So how we can use this for a very simple case. Tomorrow I will show you something more complex. So let's assume that I have a vector which is able to store point 2D pointers. And now I add to this vector manually, but we can write, a program which generates these elements, on runtime. Okay, so let's try that I create a set of objects. So point 2D 1, 5. Then point 3D 2, 6, 1, 2. And point 2D 1 or 2, or 3, 7, 1, 2, 3. Okay, let's add a new 2, 4, 6. So look, because I have a vector of points, of pointers to point 2D, I can assign both the address of point 2D and the address of point 3D. Because as I showed you before, it is, okay. And now for this vector, I'd like to call element print cout. Okay, so I'd like to print a vector of points. I don't know what happened here. Okay. So now look, I have vector of points. All of them are casted to point to decays, but depending on the real point type, so whether it's 2D or 3D, proper method is called. Yeah? So for 2D point, the method which prints only 2 dimensions is used. For 3D point, the methods which print 4 dimensions, 3 dimensions is used. Okay, something is wrong with 0 here, because I should pass here Z. But now it should work okay. So what may be benefit of using not only inheritance, but inheritance with polymorphism? Let's try to imagine that you have different objects. Let's say teacher, students, some other workers, which at the university, for example. And if we have, for every of them, you have some set of common information, but there are also additional elements. So when we try to define objects which represent students, teacher, and other subjects which work at the university, for every of them we should define a separate array. But if we create a base class, so a class which is which contains elements which are common for students, teachers, and so on, and we have a set of virtual methods to display, to process some information, we can store all these elements in single array. But if particular element is a student, and we call a virtual method, like here, print, the proper method for student will be called. when we call or use the element which is a teacher, and we call method, let's say, print, it will print the information which are specific for teacher. Yeah. So the inheritance and polymorphism led us to create very flexible mechanism, which from the one side led us to use all objects the same, so they can be stored in a single container. They have the same interface, but depending on the real type of the object, the proper method will be called. So no print for 2D, but for example, print for 3D case. Okay. So tomorrow, I'd like to make an example with polygons. So probably you remember the first class we have created. It was the rectangle, and let's say that now I'd like to create another object or another class, so C triangle. But look, I think that it's clear for you that triangle and rectangle, they have several attributes and methods in common. Yeah? So what do you think? Which attributes are common for, so can be shared among triangle and rectangle? Any idea?
The area.
Area. Okay, area as a method, yeah, because we have to calculate area. Okay, but what about attributes? So let's start from attributes. So attributes are variable, are fields.
So the side of
the side, really. Rectangle has 4, triangle has 3. So I don't agree with you that sides are can be shared between I try to find okay. So look, here we have the code of rectangle. So look at this attributes. So which of them, okay, array, I have to delete it. But we look at this attributes. So which of them will be, okay. So we have is hidden. So this one, okay. Colors, okay, it's angle. Not really. Are you able to rotate rectangle by angle and triangle by angle? Because it is rotation angle, it's not, yeah, so we want to rotate it, so it is also okay, X and Y, so it is the position of the triangle's center. So what about the center? Okay, so X. And okay, here we have sides, and sides or dimensions are, not the same. Yeah, we can define a rectangle by their sides and triangle by, different data. Sometimes we define the side and height of the triangle, but they work different. So these elements are typical for rectangle. So let's try to create a base class. This base class can be called, let's say, C figure. And I moved these elements to figure class. Not so now, because it is the C rectangle is inherit from C figure, these elements are also elements of C rectangle. Okay, so let's talk about. Okay, I see that the time is finished. So we will continue tomorrow. So tomorrow we have a single lecture, the last lecture. As I told you, I'd like to spend about 1 hour to, or maybe a little bit more, to finish this topic about object-oriented programming and to show you how we can use polymorphism and inheritance to display different features. And yes, it will be. What will be? So inheritance, object-oriented programming. Yeah, it can be an element of your exam, of course. So tomorrow I can answer your question and doubts about exams. So we spent about 20 minutes about talking about this. So you can prepare for it if you want, of course. I will try to highlight you what you can expect on your exam. It will be a little bit different than the exam which was in previous years due to COVID issues. Okay, but I'll tell you about exam tomorrow. Okay, so thank you for your attention and goodbye.